Good morning, seventh graders. Today I'm going to ask you to create a summary chart entry for everything that we have learned in our humans and carbon cycle section of our notebook. And I want you to be specifically thinking through the lens of what have we learned about the cause on an unseen level of the increase in carbon dioxide levels in our atmosphere. So to do that, I encourage you to begin by going back and looking through your digital notebook. What have we done in this section? Remember, this is your tool for learning. This is the place that offers all of the information that you need, at least as a foundation. And of course, if you want to go further, you always can, but everything you need is here. And so this is the place to go back and look when you aren't exactly sure. So let's look back here. On page 19, the first thing we did is we just reviewed the carbon cycle. How is it that carbon is moving through different places on Earth? So we have the geosphere, or like what's under the Earth, and land, the hydrosphere, and the atmosphere. And carbon is constantly moving. And this page reminded us of how exactly it is that that's happening. Next, we started to get into data and what per capita carbon dioxide rates are doing and how that compares to a variety of different factors. So you did your own carbon footprint. We compared nations. We did a lot of analysis of data on our class Jamboard, which you can go back and should go back and review. And then on page 21, you kind of took the lead and completed these two sections on your own. So what exactly does the data provide evidence for? Does the data, in fact, provide evidence that human activity is increasing the level of atmospheric carbon dioxide over time? Okay, next, we went into fossil fuels. So we always talk about fossil fuels and global climate change, or fossil fuels and carbon dioxide emissions, but what's the deal? How do they connect? So in this page here, you learned about the connection between fossil fuels and carbon. Why does burning fossil fuels release energy? And why does burning fossil fuels add carbon dioxide to the environment, rather to the atmosphere? On the next page, it goes into more detail about that. And I asked you to try and illustrate what's happening on an unseen level as fossil fuels are burned. How is that influencing the carbon cycle? If we go back to page 19, basically what we're saying is because of the burning of fossil fuels, this arrow here and here that models the carbon dioxide going into the atmosphere becomes thicker or larger than all of the other arrows, and thus out of balance. Okay, if we go down to page 25, we used the pump handle to track carbon dioxide emissions over time. And again, this one actually may be better for the evidence of human influence on the increase of atmospheric carbon dioxide. And you looked at two important trends and questions. And then from there, we talked about why we saw the data that we did. So one thing that we noticed was that there was these seasonal fluctuations. In other words, carbon dioxide levels in the atmosphere went up and down and up, all within the course of 1 year. And why is that? So this gives you information about why that happened. This was supplemental, but it's just a fun way of learning how exactly scientists gather this data that gives us insight into what the atmosphere was like long before humans were on Earth. And then today, we are looking at atmospheric levels and the Ice Age. So one of your colleagues pointed out that when we were doing the pump handle, we saw this. We saw that pre-industrial, which we learned was before burning of any fossil fuels, so nothing unnatural in the cycle. You would expect, perhaps, that this level would be the same as during the Ice Age, because both of them have a natural carbon cycle, And both of them don't have burning of fossil fuels. So why would they be different and pretty significantly different? And so based on that question, I did some research and I found out really interesting information that you read about here on this page, 28 today. And then I asked you to think about how what we learned in this paragraph right here can be used to understand what's happening as our temperatures rise. What's the correlation? What's the cause and effect or the positive feedback loop that's happening as a result of that? And that basically covers what we have learned in a nutshell. So I tried to list out the different activities that we did and the pages that they were on. I also linked our Jamboard. One thing that I didn't cover was looking at the Arctic ice data. Many of us looked at that, although I don't know that all classes got to it. So do make sure that you click this link. And when you get here, you'll see that we have our CO2 emissions data that we analyzed with our thoughts. And then we have this average monthly Arctic sea ice extent. And this is some data here. This one hasn't been marked. So you could look at this one, or you could go over to slide 6, which does have some information. But this right here is data that connects to the claim that ice in the Arctic is retreating and therefore influencing Amurvaluk and her island. Okay, so these are a lot of pieces of information to put together. And I recommend that you just take some time to think about it, fill out your chart, maybe draw a picture. How does all of this come together? I was thinking recently that it would be really helpful to maybe draw a concept map or a flow chart. That might also help you visualize how all of these pieces are connected and come together. So I look forward to seeing what you come up with. And of course, always let me know if you have any questions.